Okay, good morning class. Today we are going to cover a topic of the component of forces. In this, what we are going to do, that we are having three forces. Out of the three forces, we need to calculate the scalar component for all the three forces, F1, F2 and F3. For these three forces, the magnitude is given to us, that is 600, 500 and 800 respectively for F1, F2 and F3. For the F1 force that is acting at an angle of 35 degree with respect to x-axis, we need to calculate Fx and Fy for force 1. Similarly, for the second case, the distance is given to us 3/4 and the value of F2 is 500. We need to calculate F2y and F2x. Similarly, for F3, the magnitude is 800. We need to calculate the value of Fx, Fy for third force. Let us start how we can do this. First of all, in order to calculate the scalar component of forces, you need two things out of three. The three things are value of the force at resultant, that is given 600. Second, at which angle that resultant is acting with respect to x direction, that is 30 degrees also given. So third thing is that if the distance of x and y are given, we can calculate the angle. So now let us see, we are having this formula F1x is equal to F1 and cos of the angle. F1x for the if we need to calculate F1x, then F1 will be given value 600, cos of 35, because it is the base component, so we take cos is base by hypotenuse. The base is given to be the cos angle is given to be 35, so value of Fnx is simply 491 Newton. Similarly, for F1y, that is this value. For F1y, we know that F1 into the sine of 35 degree, because it is perpendicular over a hypotenuse is F1y. So we get the value 344 Newton. Second case. For F2, the value of perpendicular is 3, this is 4. So the value, this is given. That means case 2. If angle is not given, the values of perpendicular and base are given. So F2 along the x component will be equal to, because it is in the negative x direction, that means minus F2 is your value 3 by value will be 4 by 5, because we know that the sine component is perpendicular over hypotenuse. Perpendicular is 4 because 3 is making an angle with cos theta. So we get the value of 2yx as minus 500, 4 by 5. Similarly, 2y is 500 into cos of the angle, that is base over hypotenuse, that is 3 by 5. So we get the positive value of y direction. Similarly, we need to now calculate the F3 force. For the F3, what we will do, we will first of all see that what two things are given. Whether the angle is given, whether the distances are given. Here no angle is given, so we will come to the distances. This A is lying from here up to distance 0.4 and from here it is 0.2. So tangent alpha is perpendicular over base. Perpendicular will be, if we draw a triangle over here, this is your if this is your base and this distance will be equal to your height, the distance 0.2 will be equal to your perpendicular. So 0.2 divided by 0.4, that is the base. This one is your base. I can shift to the next diagram. Just see the elaborated part of this. 0.2, that is perpendicular, 0.4 is the base. So tangent alpha will be perpendicular over base, which is coming out to be 26 degree alpha angle. Similarly, now F3x will be equal to F3 sine of alpha. F3, your F3y will be equal to F3 of cos of alpha. And remember this thing in mind that in the y direction it is negative because coming downward. For the x direction it is positive, it is coming in the positive x direction. So answer is coming out to be 358 Newton and 716 for F31y and F31x or F3y. So this was all about a numerical based upon the component of forces. Any doubts in this? No, thank you.